Good evening, students. In previous class we have understood system adequacy, system security, quality and reliability of level. All these four factors are interconnected because power system has to be changed as per technology, as per consumers applications. So we have to design such a reliability level as per consumer satisfaction level. Today we have to discuss this concept. It is already well known that day by day the use of electricity increases because the consumer's dependence on the electricity goes on increasing. Whatever the field, either it may be agriculture, either it may be transportation, either it may be industry, either it may be education, either it may be some domestic applications, restaurants, commercials, all fields of the human directly depends on electricity. Hence, the level of electricity, quality of electricity becomes more important because consumers dependence their applications on quality and reliability of supply. It makes more burden, more thinking on utility who supplies the power to customers. Hence, a greater level of reliability are two ways we have to think. One, we have to make more redundancy of supply to one consumer than to another. This is one case. Second one, in event of disturbance or insufficient capacity, if any disturbance occurs on the system, insufficient capacity occurs when the demand is more than generation. Hence, power is forced to shut down to make the balance as per the grid information. Hence, in some other cases also we are disconnecting or interrupting the power supply. The consumers who are not paying of the bill or something misbehavior with supply authority, those supplies also cut off. It is two possibilities. And the day by day technology changes as compared to olden days. In olden days, their existing technology, their existing engineer's view, their existing engineer plan, the power system is designed. Now the days are changing, technology is changing, many softwares are coming, many sensor technology are coming. Utilization of all these technologies, the planner has to decide to provide uninterruptible power supply with higher quality to all consumers. Consumer happiness is utility happiness. The utility supplies the power to consumers. The consumers are real examiners because they know the quality and reliability of supply who are supplying. Getting the idea? That means the quality and reliability of supply is examined by the consumer applications because the consumer applications means different fields electricity can be used. For agriculture system, pumping of water. For household applications, preparation of food. For institutions, lighting purpose and laboratory purpose. In electric traction, electric transportation. In electric welding, welding purpose. Heating systems, in ovens. So, all the consumer applications are depends upon quality of electricity. If quality of electricity is low, these are all applications are affected. Consumers are not satisfied. Getting the idea? Hence, we have to decide the level of reliability which consumer needs. That is very important. Utility always makes an investment to improve the quality and reliability of supply. At present, planner has to decide what level of reliability is needed to the consumer supply. One equation you make in the mind, that is the reliability directly proportional to investment. You put the block, you remember in mind. Hence, lower reliability, lower investment. Getting the idea? For example, if I take reliability 1, investment 1, reliability 2, investment 2, reliability 3, investment 3, reliability 4, investment 4, reliability 5, investment 5. Hence, as the reliability level increases, investment increases. Here the design is mainly depends on reliability level, not on economical. Getting the idea? Consumer satisfaction is very much important rather than economical system. In this respect, cost benefit analysis plays a very important role. This cost benefit analysis provides the investment details on reliability level. Hence, it decides the level of burden on utility. It is one point understanding is that consumers are needed quality electricity just to meet their applications. They are not expecting very much high reliability. You understand my point? Reliability just sufficient to their applications. Such reliability is needed. Hence, utility also think not too much low reliability, not too much high reliability is designed, because if they are thinking very much low reliability, then consumers are in problem. If they are thinking high reliability level, then utility is in burden, more investment is needed. In this respect, we have to design, the planner has to design such a reliability level which just sufficient to meet consumer applications, consumer satisfaction. The figure 1 shows the relation between reliability increment and cost increment characteristics. You observe the figure number 1. Y axis is reliability, x axis is incremental cost. If you are thinking reliability high level, reliability 1, reliability 2, reliability 3, if you are achieving nearly 100%, then reliability is higher level, then cost is also increasing. This gives the relation increment in reliability level, increment in cost. It is already well known fact, the need of electricity changes day by day. Hence, standard of living is interposed with electricity all over the world. As today's life, the electricity needed every activity of human. Hence, the power system design and operation and maintenance and planning needs with emerging technologies. That means in olden days, the power stations are constructed as per old technology. At present situation, with modern technology, we want to construct very environmental friendly and high efficient devices, and with higher saving or more advanced software technologies in control process. This what the technology changes, the utility are implementing those ideas. It is observed that periodically revising of reliability levels, that only I am telling. As the technology changes, the need of electricity changes. The need of electricity changes, more importance of electricity creates. This means we have to meet the changing need of human, standard life of utilization of electricity. Hence, utility also goes on changing their standards, that means reliability levels. day by day. The consumer always needs their application should not be disturbed, because consumers are using electricity for their different applications. For example, the farmer may utilize electricity for pumping of water. In domestic applications, we can utilize power for food processing. In historical buildings, commercial buildings, for lighting, in welding purpose, in transportation purpose, only the consumer needs quality electricity which should not affect their applications. Has such a reliability level they expect. Hence, reliability planning becomes very much important, which can measure the consumer preference reliability. Observe, this is the plot is required for planners. So, you can observe red top, red curve represents total cost. This total cost is the sum of system cost and consumer interruption cost. So, curve 1 represents system cost. This system cost is met by utility or supplier. Number 2, blue line shows that consumers cost. Consumers cost, it may be met by consumers. Now, you can see there which type of reliability is required, where the optimal point is obtained. You can see where these two points are meeting each other. You think, for example, you take the graph 1. If system cost is low, what happens? Reliability level is low, investment level is low, but consumer have to pay more cost. Their quality affects the consumer's appliances. This is the idea. If I think too much consumer cost is less on the other side, system should have more investment, higher level of reliability. This doesn't want consumer. Consumers are happy, but burden goes on utility. Investment is high. That's why the reliability level should just required to consumer satisfaction. This is the understandable point. So, where you are getting the optimal, where you are getting the total minimum cost, at that point the consumer reliability is 100% you can achieve. Not too much high level is required, not too much low level is required. What this graph represents. Okay, sir. The total cost of supplying electricity is the sum of system cost and consumer outage costs. The lowest point on the total cost curve defines the optimal balancing. It is balancing point of system costs and consumer costs, and it also determines the optimal reliability level. These all points are very much important. From an implementation standpoint, the following analysis is also required from this curve. For each several preserved reserve margins, an optimum resource mix is determined from this optimal point. Next, for each such resource mix, production cost, revenue requirements are performed to estimate the total cost. These are very much related with one term, EENS, expected energy not supplied. Once again, expected energy not supplied, and the lowest point on this curve defines optimum reserve. This is also optimum reserve required, which can be calibrated to an optimal EUE, expected unreserved energy, which are the terms related to generation. generation point of view, and loss of energy probability, LOEP. These are all getting good point or optimal point. In a situation where the present generation fuel mix is not optimal, at that condition total cost minimization approach will indicate higher reliability of level, because some generation plants are to be added to reduce the fuel costs. You make the preparation. If question comes, briefly discuss reliability and quality planning with a suitable graph or plot, then this answer is very much worth. Make the preparation more important on the graph. Those two graphs are there, rest your explanation. Thank you to one and all.